Let's welcome Christoph for his talk about Redis multi-modal NoSQL database.
Good morning. Welcome to the second graveyard shift. It's 9:30 in the morning on a Sunday. I do appreciate that this is not a fully packed audience, but I hope everybody is somewhat awake. I'm going to talk a little bit about Redis. Hands up for those of you who are awake and have used Redis. Wow, okay, fair enough. Let's get going. As usual, I would like to dedicate this presentation to my son Luca. If you're watching, unlikely I reckon, this is for you. Okay, for those of you who have attended my talk yesterday, this will be a repetition, but for those of you who haven't, a couple of words about me. I'm a techie by training. I did all my degrees in computer science, including a PhD in reflective operating system architectures more than 25 years ago. Something that James Gosling must have studied thoroughly because the reflection API, as found in Java, as found in the JDK 1.5, is modeled closely after the thesis, or some parts of it. During the PhD, I came across an operating system called Linux, kernel version 0.95, and then I fell in love with that operating system, and I've been using it ever since. So that makes me almost a 30-year user of said operating system. I help with the local Linux user group in Frankfurt, doing a little bit of tech support and more. And I'm also an Arch package maintainer, among other things. And if there's still time left, other hobbies include anything around the software development lifecycle, IT security, and other forms of black art. And if there's still time left, I'm doubling as a community liaison and a solution architect for a company, funny enough, called Redis. I also run an open source podcast by the name of linuxinlaws.eu, commercial break. If you're looking for the latest and greatest, not just on Linux, but also rather on floss topics, with a little bit of black humor mixed in, this is the place to be. The URL is linuxinlaws.eu, feel free to check it out. In the upcoming episode, it will deal with the Halloween documents, and will feature vegan vampires and some other fun stuff. End of commercial break. How is this talk structured? A short overview for those of you who haven't used Redis yet. Then I'm going to go into the multi-modal aspects of Redis, because Redis these days is much more than just a key value store, as you probably have come across it in the first place. I'm going to talk about a little bit about use cases, and there will be a demo where I'm going to show basically how to use Redis as a full-blown graph database. And then we have wrap up and question and answers if there's still time left. Okay, Redis is about 10 years old. A guy called Salvatore Sanfilippo back in Sicily in about 2009 had the requirement for a real-time reporting project for a real-time database. He took a look at Postgres, he took a look at MySQL, he also took a look at Memcached. None of these technologies satisfied his requirements, so he sat down and started to write his own key value store, then somewhat comparable to Memcached. Over the years, Redis has developed into much, much more than just a key value store. But the main focus is still on doing anything in main memory rather than on disk. If you take a look at an ordinary database, NoSQL or not, chances are that this database basically will focus on storing the data on disk, so persistence is at the very top of that list in terms of functionality implementation. But Redis focuses on main memory, so any processing, any dealing with the data will be done in main memory rather than on persistent storage. Persistence is of course available as an option in Redis, but not the main focus. This is the reason why you see Redis being used in any use case including high performance and real-time requirements, including real-time analytics and other real-time operational topics. Some numbers. Full disclosure, this is not marketing, putting the slide in, but rather myself. Redis is probably the NoSQL database with the most client-side implementations. Redis supports about 50 languages with more than 170 client-side implementations. So chances are that for your favorite programming language, there's at least one client-side implementation. Java alone features 3. It's Lattice, Redis, and Vertex. You have clients for Erlang, C#, Forth, I think, is also available. Lisp, of course, my favorite function language. And of course, other more mainstream languages like Python, Rust, take your pick. The source code is licensed under a 3-clause BSD, so you'll find the source code on GitHub. That source code has about 10,000 commits at the moment. You have more than 100 higher-level libraries and tools. You have about 46,000 GitHub stars. That gives you some impression of how popular this code base is. And you have about 500 contributors contributing to the code base and its ecosystem. One of them is standing right in front of you, because when I joined Redis in 2018, I started to expand the standard Python client called Redis Pi with streams functionality. I'm gonna go into what streams is in a minute. But over time, basically, I concluded the implementation, and then R&D at Redis took it over, and finally, Andy McCurvey accepted the pull request. So come December 2018, you had Redis also in the standard Python client available. And of course, there's also a vibrant community on disk, on Stack Overflow. Plus, in addition to that, there is also a Discord server with various channels tackling Redis. What does Redis look like? This slide is subdivided into 3 sections. Let's start on the left-hand side. These are the native data types you will find in Redis. In comparison to other key value stores, you'll see that Redis supports much, much more than just strings. Of course, with strings, the whole thing started. Strings in Redis can be up to 1,200 megabytes large and are binary safe, per definition. So people store MP3s in strings and also MP4s and other binary data because it's binary safe. In addition to this, you have bitmaps and bitfields, you have hashes, i.e. the ability to store multiple strings under one key name, and you have also lists. Lists are quite comparable to the stuff you find in Java, you find in Python. As a matter of fact, if you take a look at these standard data types, you will see that many of these data types you will find also in your favorite programming language, whether this is Java, Python, or Lisp or some other stuff. Because that was the intention behind Redis in the first place, to give the programmers or the developers an ecosystem at their disposal that they're already familiar with. So that there is not an awful lot of mapping that has to be done from your favorite programming languages and the data type supported by this to Redis being a real-time database. Going on, you have sets and sorted sets. The difference being that each and every item in a sorted set carries a score, which makes the implementation of, for example, leaderboards or recommendation engines quite straightforward, because all you have to do is you have to attach a score to an element when you insert that into a set, and then Redis gives you back automatically in implied order. Geospatial data types essentially are longitude and latitude data. For example, given use case is, give me all drugstores within a 5-mile radius. Hyperlog is an example for a probabilistic data structure. Hands up, who doesn't know what a probabilistic data structure is? 2. All the other ones do know what a probabilistic data structure is. Okay. Just a very short explanation. Probabilistic data structure means that you only store the hash, but not the full value in main memory. Meaning, because of the fact that there may be a hash collision between 2 data items, that gives you a probability lower than 1. A hyperlog essentially gives you the number of elements with, in the current implementation, a probability of around 85% without having the requirement to store all of the elements in such a set in main memory. This is the beauty behind it. So if you want to store a gigabyte of information in a set, you don't have to allocate a gigabyte of main memory in order to store the set. But you can still have a good guess at the overall or total number of elements in this set. This is the idea behind probabilistic data structures. And I already kind of mentioned streams. Streams are a little bit comparable to Kafka as in a message bus that is focusing on transactions and gives you essentially a log-like structure. But in contrast to Kafka, Redis does it in main memory. This is the main difference, with the associated performance attached to this. These are the native data types that Redis supports. In addition to this, you have so-called modules. I'm going to go into an example for a module in a minute, but before I do that, some philosophy behind modules. When you take a look at the native data types, you see that they are quite comprehensive. So chances are, with your specific use case that the app uses, the data type is already there. But for some use cases, for example, if you want to store a graph or a document in a Redis instance, the native data types might not be the ideal fit. And this is exactly where modules come into play. Modules are a server-side extension that close the gap between the native data types that Redis offers and the more application-specific data types that applications may require. So let's go through them. JSON is a document database extension comparable to Couchbase and Mongo in functionality. And of course, all of these modules offer their own API. This is the important bit. And chances are that, at least for the most popular programming languages like Java, Python, Rust, C#, there are also client-side extensions for these modules already present. So you don't have to use the native commands that the module offers, but rather can wrap it into syntactic sugar when trying to access the functionality implemented by a module. Search essentially is a full-text search engine with auto-completion and stemming and indexing, that typical functionality you would expect from a full-text search engine. Graph is a graph database. I'm not going to go through further details because we're going to touch graph as part of the demo. So the module graph will be outlined in a minute in more detail. Time series is comparable to InfluxDB and other time series databases. AI came from the necessity to do real-time inference. The idea is to combine a popular deep learning or machine learning framework like PyTorch or TensorFlow with Redis. The challenge so far is, if you take a look at the traditional implementations of these frameworks, normally they would get the data from the disk. When you start to feed data after training the model into that model, but also between the layers. A typical backpropagation network, without going into finer details, essentially consists of a set of layers where data is passed through. And depending on the size of the data, normally you would use persistence for this, which makes the inference phase, where you're actually using a trained model to get data, to get predictions, kind of somewhat slow, depending on the overall data size. So the idea behind Redis AI is essentially to combine a Redis instance with such a popular AI, deep learning or machine learning framework, meaning that in contrast to storing the data on disk, you store the data in Redis, as in main memory, with the associated performance benefit of using such an approach, which does have the possibility of significantly speeding up your inference phase to an order of magnitude, as you can imagine. A Bloom filter, again, is a probabilistic data structure. The idea is basically you can check whether an element is a member of a set without having to store the complete set in main memory. Comes in handy when you take a look at something called content distribution networks. Ideally, basically, a Bloom filter is able to give you back a quick answer if you have to get an element from upstream or whether it's locally already in your cache. Last but not least, we have something called Redis Gears. Redis Gears is the latest addition to the module ecosystem. Essentially, it's an infrastructure on the server side, including filters, mappers, and other fun stuff, that allows the combination of modules. So, for example, in prior versions, the searching capabilities in JSON were restricted to somewhat JS query indexing. But then combining Redis search and Redis JSON would give you the full indexing capabilities of Redis search in combination with Redis JSON. This was the idea behind the initial development of Gears. Gears, but also Gears has one additional advantage. Gears allows you to ship business logic to the server side from the client side. At the moment, the programming language support is Python. So if you have a big data problem or something like this, written in Python, you can actually ship your business logic that executes the code on the client side to the server side. So that saves you potentially a lot of time on round trips. Other programming languages, and of course the beauty is that this business logic will then be executed as part of the server context with the associated benefits like high performance, low latency, and high throughput. Python is supported at the moment. Other roadmaps like Java or essentially other programming languages that support a C binding are planned for the future, meaning that over time you will be able to ship C code, Java code, and other programming language directly to the server, rather than having to do round trips between the client and server side with the implied performance penalty as such. And of course, Redis being an open core company, you do have a commercial version available, which has some functionality that is not available in the open source version, but this is not a presentation on the version called Redis Enterprise, but rather on the open source version. So if there are any questions about the enterprise features, feel free to approach me after the presentation. Let's take a look at Redis Graph. Who has worked already with the Graph database, like Tiger Graph, like Neo4j, to name but a few, or Rango or something like this? Nobody, okay? In that case, let's do a quick recap of what a graph really is. A graph consists of nodes, edges, labels, and properties. You see an example of a graph on the left-hand side of the slide, i.e., if you want to model a relationship between an author, a book that the author wrote, and a potential buyer of that book, you essentially use the author as a node, you use the book as a node, and then you use the buyer as a node. And the edges between the nodes express the relationship. So in that case, Jean Le Carré wrote a book called Tinker, Tailor, Soldier, and Spy, and that was purchased by a guy called Alan on the 7th of May 2011. So the nodes and the edges can have so-called properties and also labels. That's exactly a sort of meta information attached to these entities that give further details of what exactly is contained in these items. This is the idea behind a graph, and essentially any graph database will model this relationship in a very similar way. So Tiger Graph, Neo4j, Arango, whatever you pick, and of course Redis Graph as well, will basically use that approach in order to model graphs. Graphs are becoming more and more important as a primary data structure, not only for social networks, but also, for example, for fraud detection. As a matter of fact, if you take a look at credit card transactions, if you want to detect credit cards, a credit card transaction done at a local merchant will give you the transaction as such. But if you want to take a look at if a credit card has been used in various locations in a very short amount of time, what you actually have to do is you have to correlate that information, i.e. you have to take a look at the credit card number and at the date that credit card was used in a location. And that's exactly where the graphs come into play. And the quicker you can do this, the more accurate that correlation will be. And that's exactly the reason why major credit card companies use graph databases featuring real-time properties to actually detect fraud in that area. A couple of details on Redis Graph before we go into the demo. Redis Graph uses OpenCipher as the query language. OpenCipher is rapidly becoming the industry standard. Think of it, to quote a legacy technology, like the SQL of graph databases. Then you pretty much have it. In contrast to other graph databases, Redis Graph uses something called sparse matrices. When you take a look at your typical graph use case, you will see that only a few nodes are connected to each other, and the rest of the nodes will not have any direct connection. The idea is behind this to model this in a matrix, meaning that you have the axis of the matrix as the nodes, and then wherever there's a connection between the nodes, there's a 1 in the corresponding spot in the matrix. Because most of these matrices are pretty sparse, you can implement this very efficiently. And that's exactly what Redis Graph does. That reduces multi-hop queries, i.e. you want to take a look at what edges are, what nodes are connected to one node, to a simple matrix operation. That either can be done by the CPU or much more efficiently by the GPU. This again has the advantage of giving you an additional speed up. For doing that, we use something called a Graph Blast library. The Graph Blast library is an open source implementation dealing or focusing with sparse matrices. The beauty is, as I said, Graph Blast is able to not only use CPUs, but use GPUs in addition to that as well. Meaning that gives you a pretty good performance if you have such a hardware. This is the reason why when we did the initial benchmarking, we came up with the result that you would get about 10 to 50-fold that you would get a performance gain of around 10 to 50 times, depending on the use case, to your ordinary, say, Neo4j or Rango database. And this is especially important if you take a look at real-time, because that's exactly the benefit that you get when you're using Redis Graph. Clients, of course, available include compiler-based ones like Rust, Golang, Java, and C#, but other clients are available too, like Python, JavaScript, Ruby, and PHP. The website is called redisgraph.io, and on that website you will find a list of clients and implementations. Demo time. Let's take a look at how it's done. I'm using Python for this. And the idea is essentially, I'm not going to walk you through, in the interest of time, I'm not going to walk you through all of the details, but rather focus on the structure as such. Essentially, the first couple of lines connect to an existing running Redis Graph Redis instance, and then I'm using a Python implementation called Redis Graph -py, which is the standard Python client for Redis Graph. Then I create a couple of nodes that model a journey graph database, i.e. you have a name, and you have a country, and you have a purpose for that person visiting that country. In that case, business and pleasure. So essentially, there's a guy called John Doe. He's 33 years of age. He's a man, so he's of gender male, and he has a relationship set of single. And then we have a country called Japan, and that again is modeled as a node, and then we construct the graph by simply saying that please connect John to Japan with the purpose of the trip as in pleasure. So it's not a business trip, but rather a vacation. And we do the same for Pearl White and Mary Miller for the countries called Australia and Germany. Once you've created this on the client side, all you have to say is Redis_graph commit, as in you invoke the method commit on the graph object, and that will actually ship the graph. Then that will commit the graph to main memory on the server side. With that, this is all you have to do to create a graph in Redis Graph. It's as simple as that. If you want to query this, again, it's straightforward. So you just have an iterator. That gives you back the purposes of the trips. So essentially, you construct an OpenSUFFER query in line 44 and 45, and that gives you back the full graph structure. And all you have to do is then issue the query, and then printRes is a pretty print defined up here that simply lists the relationships as in the edges and the nodes on the console in kind of a couple of lines. So let's execute this. And this is the demo effect. No, great. Sorry about the glitch. There you have it. essentially the only pleasure, the only vacation is actually that the trip that John did to Japan, and the rest of the 2 trips were actually done for business purposes. This is a nice output, and of course all this is running locally, by the way, but a graph really asks for some sort of graph visualization, no? So let's take a look at something called Redis Inside. Redis Inside, for those people who may have come across this, in that case you already know it. For those people who haven't, essentially it's a browser-based front end to a Redis instance. Essentially it's called test, and this is all running locally. So I can browse the whole thing. What that would give me, and of course the graph is called social because that's exactly the name that I gave it on when I created the graph on the client side. But of course you want to take a look at rather of how the graph really looks like. So essentially you pick the graph, the query is already defined here because that's what I entered previously, and you simply execute this. And then it actually gives you back the 3 relationships as graphs themselves, which is kind of fancy because that basically goes beyond the simple text representation. And of course, that's a very simple example. Of course, you can construct much more complicated ones in the very same fashion. Okay, to recap. Redis is a flexible multi-modal in-memory NoSQL database. For the reasons explained, the idea is basically to give you ultra-high performance at very low latency, because Redis does it all in main memory. You have already kind of powerful native data types, as explained, but then on top of that, you have an easily extensible module ecosystem that gives you additional, more application-oriented data types. The beauty is that the module SDK is, of course, defined. All it takes basically is a programming language that is able to use C bindings. Of course, you can write your own modules because the API is specified on the website. So you are free to take a look at how it's done, essentially. Gears, I already kind of touched on this, is a module infrastructure with the addition, with the feature or with the ability to ship business logic to the server side, thus already giving you an additional boost with regards to performance. And of course, you have the very kind of comprehensive set of client-side implementations. Something that is probably worth mentioning, Redis has an ultra-small footprint. I'm running Redis on an ARM v5 that is a single core v5 ARM architecture with 512 megabytes of RAM. That Redis instance is powering 4 FPMs, that is an PHP application server, and in turn powering 4 or 3, it's actually 3 Nextcloud instances, all in one machine, in this 512 megabytes of RAM. So if you take a look at a running Redis instance, you will see that the RSS and the virtual memory side is really small. Of course, you can blow it up by putting more data into it, but the server itself has a very kind of small footprint, which makes it ideal for like IoT use cases in addition to the ones I already mentioned. And I think we still have about 10 minutes time for questions, if there are any. Yes. Whoever has a mic? Dankeschön. It should be turned on. No, yes? Can you give it a... If the mic isn't on, maybe we should unmute. It should be unmuted.
It's already...
Yeah, thank you.
Okay, thanks. So how do you envision, if we want to develop our next killer application, do you envision that this replaces the existing SQL technologies, or it coexists? What's your vision?
I wouldn't say it would replace existing SQL technology because Redis is a NoSQL database. So you have the advantages of a NoSQL database, i.e. no fixed structure, But Redis gives you all the components that you actually need if you model a SQL-based a SQL-based approach. So, for example, you have the building blocks in place to have full asset compliance, i.e., you can implement transactions. Redis doesn't offer asset compliance out of the box, but the building blocks are there. So all you have to do is basically program it. A NoSQL database goes beyond just ordinary SQL functionality, goes without saying, because otherwise we wouldn't have this budding ecosystem of NoSQL database, and Redis is one of them. You have MongoDB, you have CouchDB, you have Rango, you have InfluxDB, just to name a few. Going forward, more and more people actually discover that in comparison to traditional databases that, for example, focus on full asset compliance, they come to the conclusion that they don't need all these features because they come at a price. Asset compliance, for example, is very performance intensive because you have to go through the commit phase, then you have to commit the transaction, or you have to roll it back, and that all costs cycles. So quite a few applications actually can live with something called eventual consistency, where as an asset compliance would give you immediate consistency. This is the difference between them. So it really depends on your use case, but I do see a significant uptake, especially if you're talking about mobile or other IoT use cases going forward, i.e. where you move your stuff to the edge or to mist computing or cloud computing as such. Plus, of course, that NoSQL databases generally are more scalable than ordinary SQL-based approaches. I hope that answers your question a little bit. Other questions before we come to the competition? No questions. Okay. I have one T-shirt, of course, in different sizes, for the person who can answer me how old Redis is. I mentioned that at the beginning of the talk. So whoever comes up with the correct answer, as in how old Redis is, gets a T-shirt. I mentioned this at the beginning of the presentation. Almost right, but you have your T-shirt. Come to me after the talk and I'll give you the correct size. Thank you.
Thanks for your informative talk.